and makes all kinds of codes all over the blade. So if it's in area A, you can do certain repairs. If it's in area B, or they'll have other codes too, you can do certain repairs. So we're going to look at that, but that's just manufacturer marks the blade or gives you a way to identify areas of the blade where some are more repairable, some you may not be allowed to repair. But if you can do it by blending, which is a hand method to recontour the damaged blade and vanes using common or die sinker type files, crocus or emery cloth, or India or carborundum stones. So because of the type of material, you may use that. Always go to your manufacturer, obviously, and see what they say. And it's really important, now this is a really, really long blade, but you're always blending parallel to the length of the blade. Don't ever go across your blade. Why do you think that is? You can just read the rest of that.
Causes stress in the blade. Minimize stress points.
Well, I said smart. I mean, you are actually. So you want to minimize stress points, restore a smooth and aerodynamic shape as possible to the surface. So we want, and we're going to talk about this with prop blades also. So, oh no, we're losing it. So on a prop, like this is a rotating airfoil, just like a fan blade is a rotating airfoil. So prop blade, fan blade, compressor blades, all of them, when you reprofile or blend it out, you must always go this direction parallel to the length. So this applies to this will apply to prop class. No going back and forth, because now you're creating stress risers like that. And what will happen if I have a crack developing like this? Bye-bye, it departs the aircraft. On turbine engine, prop is really bad. You do the prop, you're out of balance, shut the engine down, hopefully you can glide somewhere. Here, that remnant could go back and destroy your entire engine. Really bad. Questions on that? Here's something that you'll see questions on. Fan blade shingling. So I don't know if you remember way back when we first talking about fan blades. In older ones typically will have these mid-span shrouds. So this is a pretty good picture of it. That's a good picture of it. So here we have these shrouds kind of going from one blade over to the next shroud. And if they overlap, so if you have these shrouds starting to overlap, gives you really detailed information. So, yeah, just, that is what it could look like when you look at coating on a blade.
The turbine blades, is it as important to have uniform thrust along the blade?
They must have their correct airfoil because they're extracting energy. You cannot repair turbine blades. They are replaced. Well, this is just compressor blades.
I'm talking more the design of them, because
Right.
I see you have this chain with angle attack along the length. But
Yeah.
then it's also getting wider towards the top of the blade.
So this is just a compressor, one example. Well, actually, no, this is a fan blade. No, low pressure compressor, rotor, blade section, yeah. So yeah, it would depend on your engine, the fan blade, compressor blade, what section of compressor.
So some length, some length.
But they'll still have very specific contours. And when you go to repair a fan blade or a compressor blade, you absolutely must go to the manual. Not only for this detailed information, but further on, it'll say things like, so say, take a blade and you're going to contour it, file it. You need to mask the surrounding areas so you don't accidentally file something that's good. And if it's titanium, accumulation of titanium dust is a fire hazard. So now I gotta protect the surrounding area, make it fire protected. And then when you take the tape off, when you're all done, and you take the tape off that's protecting the surrounding areas, now you have to use like isopropyl alcohol to remove the residue from the tape. And then you have to do a vibration analysis test run on the engine. So it's not like you can just go out there and like, whoop, we got a little nick, beep, 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 beep. All right, done, go. That's a whole process with a lot of things you have to follow. Questions on it? Axial compressor inspection and repair. So now we're moving behind fan into our axial compressor. These are two totally different engines. Minor impact damage to compressor blades can be repaired on the flight line or in the shop if the damage can be removed without exceeding allowable limits. When repairs are completed within allowable limits, there will be no compressor imbalance, and balancing checks are usually not required. So that's how the manufacturer makes all those coatings. They're like, okay, if you stay within these tolerances, you don't need to do a balancing check. But it's really important that you keep those tolerances. And if it has a centrifugal compressor rather than an axial compressor, centrifugal compressors can only be repaired by approved overhaul facility. We can't do any repairs on it. Yeah. But, I don't know. Do you know what that's also?
One of those big airliners, G90, big Rolls-Royce, RV211s, all those great big high bypass fan engines on the airliners.
Other question? Here is a cool thing. Electron beam welding. I think I mentioned it at the beginning of the class. But electron beam welding now permits the reworking of many compressor blades that formerly they would have been unserviceable. So they've been beyond their limits. But now they can do electron beam welding. Especially useful in titanium alloy. Allergies are bad today. From which many blades are made. Lots of blades are made of titanium, and that's where electron beam welding works. And if you use this process can use. Really valuable to return compressor blade tip clearances to their original specifications. And why do we want as close as possible on our tip to our case? Best efficiency, yep. We want to harvest all that air that we can. So with this, you could take a large engine with 0.035-inch cold tip clearance down to 2,000 of an inch clearance during operation. So a whole lot better. And if you have inadequate tip clearance, that could result in galling, which is a term you can find in your textbook. Your textbook, page 10-48. 1048, if you have not done, I forgot which lab it is, I think it's lab 11, where you identify a bunch of blade defects. 10-48 will really help you with terminology, a whole bunch of terms and their definitions of damage. Whenever you're doing maintenance on an engine, something you need to know is industry standard to describe engine locations is you're standing at the back of the engine looking forward. So this one, sitting at the back, looking forward, and that will clock it. So 12 at the top, 6 at the bottom, but then 3 o'clock is going to be over here. There's 3 o'clock, 3 o'clock over here, come around to 9 o'clock over. Just be aware of that from the back, looking forward. And that's the same thing on this one. If we have counterclockwise rotation, it's going to be this way, from the back looking forward. Clockwise rotation will be this way, from the back looking forward.
2, 3, and 9 o'clock positions switch toward the clockwise rotation versus counterclockwise.
No. No, it'll always be 3, like, yeah, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Always.
So the reference clock is always clockwise.
Correct. And then rotation, we would say our gas generator turns counterclockwise and our power turbine turns clockwise, but we'd still say, okay, this is my fuel nozzle at 9:30 position or something like that. Other questions on that? Blade replacement. So, remember way back long ago, when you had weight and balance class? Ha ha ha. If you thought you were done with that, you're not. Because each of these blades has a specific weight and must be balanced. It has an arm. It has a moment. So, blade replacement is generally allowed with a restriction placed on the number of blades replaced per stage and per entire rotor. So, on this one, for one stage, I could replace so many blades. But if I replace, let's say my limit is I can't replace more than 7 on a rotor. But maybe I can't replace more than 14 in the entire axial rotor. So if I take one stage and I replace 7 blades, and then another stage, oh no, I replace 7 blades, and then my third stage goes bad, well, I've exceeded my amount for the entire rotor. I got to get a new stage. So, have to stay within all of the limits. And then blades are movement weighted and already talked about coded to provide means on exact replacement for maintaining compressor balance. Because if your compressor tell you. Even number blade, you replace the pair with the opposite blade, so you're replacing two blades. Odd number, you have to replace three blades, like this. So if you don't have the exact match, now you have to replace with the same type blade, exact same, opposite of each other, so you maintain balance. If you don't have a blade exactly opposite, then you have to do 120 degrees to maintain balance around. The manufacturer will tell you if it's odd number or even number blade. Right.
But it's not always gonna be evenly divisible by three either.
It should be one or the other.
Say that again?
If it's not divisible evenly by three.
Typically would.
Yeah. They'll design it one or the other. So that that can be done.
It's just more expensive if you got odd blades, or you have to do it with threes, instead of by three blades, which they're all gonna be from the same mold blade, just to maintain balance. But for the most part in the industry, it's usually pretty common if you need to replace one blade, you look at the molded weight that's etched into the root period. You'll usually find that manufacturers usually not.
The questions on that. Here's an example from the JT15. Just what it could look like. So they'll tell you the clock direction and give you counterweights that might be in those blades, rivet holes, weight, whole bunch of directions for adjusting, testing, inspecting, checking. But that's what you would be looking at for blade attachments and more on coding. Stator vane and compressor case inspection and repair. So, repairs of slight impact damage to stator vanes and compressor cases may be generally repaired by blending. Cracks may be weld repairable with traditional inert gas welding apparatus. So if I say that means it's a weld inside a shield of gas, what kind of welding would that be? TIG welding. So it has to be TIG welded by an approved station. Hot section inspection and repair. So in our combustion section, cracking is going to be one of the most frequent discrepancies because it is so hot. And the most common method you've already been doing to check misalignment, cracks, hot distress. Some of us experience cold distress. Engines experience hot distress. And use a borescope. Have all of you used both the flexible and the rigid borescopes? If you haven't, just try to get experience with both. They have different illumination, different magnification. You have 5mm ones, larger ones, expensive ones, cheaper ones. Your manufacturer will tell you recommended schedules for borescoping for preventive maintenance. What to borescope when. You've been borescoping, but I wanted to make sure to mention borescope care. Always follow the borescope manufacturer's guidelines. Know how to properly handle it with a fiber optic cable, so no kinking it. Keep a good radius on the coil. Be gentle with them. Make sure you properly clean them according to manufacturer. Store it properly. Don't just slap it down on a table and throw something on top of it. Then we malfunctioning fuel nozzles or other fuel malfunctions. So then if you see a hot spot, how to know why is that there, what nozzle is going wrong, I need to fix something further down the line. Turbine section. Also use a borescope on this section. You can go visually through the tailpipe, strong light mirror magnifying glass, or the borescope. Or there are, I know for the PT6, there are scheduled hot section inspections. I think we talked a little bit about this the other day, where you actually remove components, get this all loosened up, remove all these bolts, and remove the whole forward section of the engine. And then you can get right in there and look at your power turbine, remove that, really look at compressor turbine. That is an official hot section inspection. But you can use a borescope too. How do you access looking at your combustion chamber? Yeah.
Fuel nozzles.
Yeah. So you just remove a fuel nozzle, look in there. You can look at a lot of stuff. Come around, curl around, look at your turbine inlet guide vanes. Or you can come through the exhaust and look at your power turbine. Look at all that you can on the exhaust section. So you can see a lot with a borescope. And come to the inlet, look at the compressor section. You may be able to remove accessories, look at your accessory gearbox. Lots of things you can see with borescoping. Really, really useful tool. So, back to hot spots. They are the first indication of malfunction in fuel distribution. And you may have a streaking nozzle. What sorts of fuel nozzle or a crack cause in spray nozzles? What kind of defects have you seen in your spray testing with Nick? Yeah.
Loose tip dripping.
Ooh, dripping. So should have this nice stream, but it is like a drip, 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 drip. What are some others? Streaks. So you have seen streaks, like a heavy flow in the middle. So that fuel nozzle would cause a hot spot. Cause hot streaking can cause a flame to penetrate through the entire turbine system to the tailpipe. So if one of these guys goes bad, it can send a flame. Since these are aimed this way, it'll cut right through our combustion liner, right through here, maybe penetrate into our shaft. And that's caused by partially clogged fuel nozzles. Now it's no longer properly atomizing that fuel, but an actual stream of fuel is coming out, and that is sufficient force to cut through that cooling air blanket that's protecting your combustion liner, right through that, boom, impinges on your actual combustion liner into turbine surfaces, and it's a bad thing. Questions on that? Stress rupture cracks. Have you seen any cracks on anything you've been borescoping? So, on turbine blade, leading or trailing edge, you'll see a crack starting working across it. They are of concern, and you will initially see them as a tiny hairline crack, and it'll be at a right angle to the blade length. And you can also have like a rippling of a turbine blade. I think some of the examples on the table show that, and that'll indicate serious over temperature, and then special in-shop manufacturer's inspection will probably be required, so I have to send that in for them to inspect it. Always refer to your engine maintenance manual, because that will tell you specific allowances. Here we got really bad problem on, let's see, father and So here is unacceptable damage. Examples: sulfidation, erosion, burnt material, FOD. Here's acceptable damage. So just a coating loss rather than actual sulfidation eating away at that. A little bit of coating loss, a little bit of erosion. So it will show you differences between acceptable and unacceptable damage in your maintenance manual. Like Kirk mentioned, when they code the blades, they will mark it on the fir tree section. So it'll indicate the moment, weight, in either inch ounces or inch grams. And then you have it marked on the root of the blade. Creep and twist. These aren't bad dudes in the back alleys of Ionia. Thank you. These are terms referring to what can happen to your turbine blade. So I kind of want to do it like a radio show now. Creep and twist. So creep is a term used to describe the permanent elongation which occurs to rotating parts on a turbine. Is most pronounced in actual turbine blades because we have a lot of heat back there and heavy centrifugal loads trying to make that blade go bye-bye. So tend to stretch it out. A term you need to be familiar with is accelerated, also called tertiary creep. Accelerated creep during an engine's life can be attributed to any of the following. So have a hot start or over temperature, extended operation at high power with high EGT and centrifugal loads, or erosion of the blades from ingestion of sand or other foreign objects. So the blade grows longer and longer and it ain't going back. It's stuck longer. Turbine case, vanes, and exhaust section. So turbine section parts, just like human beings, they record all abuse that occurs to them. And they, that's with them forever. So in operation as well as normal aging process. And that shows up as cracking, warping, bowing, eroding, and certain types of small visible cracks may result from thermal stress. And that can happen even if it hasn't been abused beyond use. That can happen just from normal operation. It's getting older. Heat has an effect on stuff. Centrifugal forces have an effect on things. So even if you're flying the aircraft and you're like doing exactly by the manufacturer, taking care of it, running it really nice and smooth, it still must have your inspections. It's still going to age and start to have problems. If you need to mark turbine engine parts, there's specific things that you need to use and some things you must not ever use. So this is if you need to identify an area that you need to be repaired. So both for hot and cold section, you may use chalk, special layout die, or commercial felt tip applicator, or special marking pencil as approved by the manufacturer. And if you're going to use a Sharpie, it needs to be trace element certified. Can't just be any old Sharpie. Or here we have, I can't quite read it, but a special layout die. Now, y'all can read. I want you to read with me. This line right here. Never use a lead pencil or wax And then the special marking pencil, this one here is a special marking pencil. All the little numbers on it, you have to make sure it matches the manual, and Pratt approves that. So these are two things that you'll get if you go to PC6 school at JARS. So it gives you your own to take home with you.
Always follow the manufacturer's maintenance manual for that specific engine or what they want to use. Now, the reason why you never use a lead pencil, what is a lead pencil made of? What's the element of a lead pencil? Graphite. So when that graphite gets on a turbine blade or any hot section part, case liner, that graphite is carbon, just pure carbon. So it starts absorbing that heat, and it gets so hot in that area, and you cause crack and so on and so forth. And that carbon, if it gets hot enough, will actually infuse into the metal and now change the alloy. And then the heating, cooling between that will crack that area. So you can never put graphite in a hot section part.
Yeah.
If we use lead, because you get lead deposits anyway if you're running out of gas.
Oh my word. Follow the manufacturer. If you want to do that on your own engine, let it fall apart. Any other questions? All right, take a break and come back at 35. 35.
There was a time when, yeah, it's definitely, it's like, it's a crayon. Bro, it's a crayon. Do you know how they spell it? I don't care. I do not care. Nope. It's a crayon. I can see crayon. Nope, it's a crayon. Huh? Bro, I'm already bringing your crown.
I didn't say it was, what is that we call the hot
Yeah, I'm okay. Sure.
You don't look at that.
I'm very startled.
Because Thomas just lost his, but I think that was Sam's fault. Did you refresh his page while he was doing it? Oh my god.
You should know this by
What were
now.
you expecting to happen when you hit the page? Were you expecting it to save? So,
You're talking to Sam there.
So-
I mean, shoot, this.
ethically, at heart, you are an evil person.
Yes.
Because you had no good intentions behind that.
Yes.
That
And
is.
ignored it. No, ignored it.
Not ignore it, no.
Sam Gaines. Don't ever call Sam Gaines. He's one of the nicest, kindest, lighthearted people I've ever met.
Aviation mechanic, by the way.
Samuel
This
Gaines.
guy's keeping you safe when you're in the sky. That's
Yeah.
That's pretty good.
Yeah, 1.0 GPA.
Yeah. Point A GPA activity. That NFL contract.
Bro, I'm getting that Amway job for real.
Yeah, man, maybe that sweet for free.
I have to pay them to clean their floors. Shoot, imagine that. Oh, yeah? Remember how like day 1 or 2 of school, how old the strategy was so prim and proper?
I can't tell if I'm better or worse, but
And
it's
then
like,
me at the beginning of the year compared to now is like,
Imagine if you started the year being like the way you are.
yeah, no,
you would be here.
I need at least 4 months to 5 months to settle. Yeah. The parasites inside.
The chemicals in the blood.
What?
Turns out.
Who?
What's this?
Intake. Axial intake.
Brushed his head. Are you gonna watch this?
Okay, rotor stator. Oh, rotor. Stator. Rotor. Stator. Rotor. Stator. Centrifugal thrust. Rotor.
Yep, and then what's this?
Diffuser. Highest point pressure. Oh wait, here? Yeah, highest point pressure. No, this is the highest point pressure. This is the pressure.
That might be the worst.
Freewheel pressure section, turbine blade. This is the compressor turbine. This is the compressor. This is the turbine compressor.
What?
It can power turbine
Yeah,
compressor.
this is stator.
Oh, this, yeah, stator compressor turbine. I thought
Compressor
Give you a schedule if you show
compressor
up or
turbine is
compressor turbine.
There's a schedule, but they schedule us with the bare minimum. They pay 4 weeks of work, 3 weeks. At most,
This thing?
normally on schedule, they do 20 minutes apart, but with how early planes are, they always
It's not fuel.
That's like Burger King soda.
there's no wind.
You know, there's like an arm on here that moves.
I don't think I'll be able to pass
Speed.
that safety test
could be a
Lyle makes us do. I'm so tired, I'm like,
Oh, you know what? It might have to do something with yeah, it's got this. It could be something
I'm
with
sure I'm not the first
feather.
person. I definitely
Do you know that lab where you have to go through and basically need parts of the PT6 like 6 times over? Middle of class, no preparation, no books, you got 95.
Estimated. It's estimated.
I can't believe, I will say
I
this is
feel
the
very
only
proud
part
of
of
our
our
actually
experience
just
with the gal that was running the drive-thru.
No.
The calmest voice. The
I thought you
calmest
were
voice
gonna
I've
try
ever
to
heard in my life.
knock you down to grade level. No, dude, I know that's bad. I know that's not.
Shark on.
That can
I'd
not.
answer.
I think you agree with me. I feel like when you're done.
And answered.
What?
Oh, Fit. I should make a contact named Fit. It should be Sean to
He's a
call
little
like
smarter
Fit.
than me. I went to Arby's.
0.8 GPA. 0.8.
Yeah, and guess what? I might be the worst aircraft mechanic out there too.
That's not a good thing.
Or I could be mild at best.
No,
God,
I've seen some
Tyler.
pretty bad.
Try
Go
harder.
talk to your wife about being a lawyer.
I was like,
You aren't getting enough.
I'll have you know, I'm doing my airframe in a couple of weeks. It's been scheduled. And I'm getting caught up in labs at a rapid rate.
Keep it up.
No, because I go through big waves of I'm gonna do a bunch today, not tomorrow.
That's me. I'm the same way.
Unfortunately, it is how I am, and it will not change. Sorry.
I think it's a part of the TISM.
It is part of the TISM.
I completed 3 practicals today, and remember how long I was not doing any practicals? Like one day I did 3.
Yep. It's part of the TISM.
Yep, it is in fact the TISM.
Yeah, and this
I
is
finally got my stupid bag to work.
good for you.
By throwing it out and chasing it. I was,
Give up.
no, I was setting it all right up.
So you have to start over again.
No, I took it apart.
Like a regular Sharpie. Any kind of like metal element.
Only the best for airframe mechanics. What are you doing today? Hey, you better not do. Hopefully one will. What you do, I do. Clearly no one will.
I don't say I'm sending a text. They wrote nothing in there.
Which also surprised me, right when the sun got so
Gather in, gather round. Yes, sir.
Actually,
I saw her say you
because my screens are bigger.
Gather in, gather round. Let us commence the fun and exciting lecture. Hey, Joe, turn. Thank you. All right, now as we move on with the lecture, I hope you can bear with me. Oh, not that one. Oh, that was such a fail. There. Haha. Joe didn't even.
I didn't see that one coming.
You missed a really good one because you weren't in. Bear with me. So, we're going to talk about bearings. I mentioned a number of times, we're going to talk about bearings. We're going to talk about bearings. Guess what? Now, we're going to talk about bearings. So, in turbine engines, we are going to use either ball bearings or roller bearings along our shaft. So main bearings of gas turbine engines are either ball or roller anti-friction type bearings. The ball bearings, which we have a little balls in there, ride in a grooved inner race and support the main engine rotor for both axial thrust and radial centrifugal loads. So, if this is the shaft of the engine, and I'm the bearing around the shaft, if it is a radial load, now I'm going to push out on these guys radially. So I'm pushing out this way. Sorry. If it is a axial or a thrust load, then I'm pushing this way along my axis. So that is why they are designed the way they are. So the little ball bearings, they can take loads this way and this way. And our roller bearings are just for loads this way. Questions on that? Anybody want to offer a better demo? Okay. So the roller bearings, flat inner race, because they have greater surface contact than ball bearings, they're positioned to absorb the bulk of that radial loading to allow for axial growth of the engine during operation. Let the heat up. Bless you. Self-expand.
To help draw a picture in your head, if you had a very large fan on a shaft and it's rotating, it's in flight, and it's rotating whether that, when you go to full power and that engine is trying to go forward, you know, everything is transferred to the bearings and shaft and everything else. But here's a special question for you to ponder. When that engine is attached to an airframe or attached to the wing, is that jet engine pulling the aircraft or pushing the aircraft? Never mind, go ahead.
I'll let you send that. So, with all bearings, you must handle them with care because we just talked about the load that they are under. They're supporting that shaft. So you must wear lint-free gloves. A bearing set must always match. And I was gonna grab a bearing and I forgot to. But don't, I know you're tempted. Do not ever take your bearing. You know what I'm gonna say. Take shop bearing, go. Now you just ruined it. So if I see you doing that, I'm not allowed to smack you on the head, but I want to.
Am I allowed to smack him on the
I
head?
think you can. Yeah. So I'll call up Kirk
Not
if
like I'm
he's
gonna
not.
lose my job or something, right?
Right.
Kirk is irreplaceable. Back to everyone wants.
Alright. Here is just that picture I had up there, expanded. You can see their little roller bearings in their little cage, and then, I'm sorry, ball bearings that are shaped like little balls, and the ruler bearing. Both have the inner ring, the race, and then the bearing.
Yeah, that's why we use them on wheels too, right? All the wheels are roller bearings, so take that weight, that load.
Questions on the difference between ball bearings and roller bearings? So something that is really important with bearings and some other engine parts is if you removed them, you inspected them, they must then be checked for the presence of magnetism. And have you played with a little Gauss meter? You should have. Oh no.
Some have, some
Okay. What about when you did the Magnaflux? Oh, that's coming up though. No, you did that. You did that. Yeah. And did you check that your parts were degaussed?
Yeah.
Way back in general. Yeah. So you had, and it might have looked a little different than this one, but a little Gauss meter to make sure there is no residual magnetism. If we shoved our bearing back into the engine and it did have a little bit of magnetism, what would happen? It's gonna go, oh, metal shavings, come here. And then what's gonna happen? It's not gonna be a bearing anymore. It's gonna shred itself, shred whatever's next to it. You lose all, yeah. desktop degausser, or countertop, or you can have a hand wand degausser. So there's lots of different types and styles out there. But if you do find residual magnetism, it must be degaussed. And I think you might maybe be seeing that kind of question sometime Tuesday. You find magnetism. What do you need to do? Degauss. So here's fun fact of the day. These are the bearings on the PT6 engine, just to help you get a picture of ball bearings versus roller bearings. And it's probably hard to see. They did draw a little circle for the ball bearings and made a little flatter thing for roller bearings. Pretty hard to see. But these are numbered from the back of the engine. Just like I told you, everything is from the back of the engine forward. And our number 1 bearing is for axial and thrust loads, so that guy's a little ball bearing. And then we have roller bearing, and then another roller bearing, ball bearing, yes. Wait, no, that's roller bearing. There's a ball bearing. This one is actually going to the power turbine. So that's why he needs to be a ball bearing. And then coming up here is going to be roller bearing. And that's out to our reduction gearbox to the prop. And then a ball bearing on our shaft to the prop hub. And the PT6 has technically 3 shafts. Each has 2 bearings, and then, yeah, a little extra guy. And it'll have the gas generator shaft, power turbine shaft, and the prop shaft are considered 3 different ones. And something to note on when if you're removing or installing bearings, some of these, so here, to install it correctly, the serial number on the bearing goes to the rear. Here, serial number goes to the front. So little tiny details like that are going to be in your maintenance manual. And never ever mix bearing components. So intermixing of bearing components is strictly unacceptable. So don't do that. Questions? And now we'll talk about bearing seals. And this is in your textbook, page 1-54. Talks about it, and then there's some good pictures of it. But most bearing housing contains seals to prevent the loss of oil into the gas path. Oil seals will usually be of either labyrinth, we'll look at, or carbon rubbing types. And it's common to see either one or the other, or a combination of both used in the same engine. And this here, a brush seal, is the newest generation of seal and becoming more and more widely used. And it has backward angled alloy bristles that are immune to rubbing and maintain original clearances. They are larger than, we'll look at a labyrinth seal, so larger than just a labyrinth seal, but they help minimize surface to seal it. So here is our main bearing. What kind of bearing is that? Got a ball bearing in there, so that's our main bearing going the whole way around our main rotor shaft. And here is our labyrinth seal around it to seal the oil into that bearing so it doesn't escape. It stays keeping that bearing nice and oiled. So we're taking that pressurized air from our compressor bleed air and pouring it in here to seal off that area. And inside of here we have our little oil jet squirting oil onto our bearing, keeping it nice and lubricated. And this little air seal, so this guy is also around our shaft, and the air comes in here and comes out here to have an air seal against the shaft and with the bearing. And then we have overboard drains, and our oil in here goes back to the scavenge tank. So yeah, air pressure between those grooves pressurizes that seal, and one part will be stationary and the other part rotates with the bearing. Kind of actual little picture of our components and all our little grooves and portions that our air will come through. And here, it's kind of hard to get one big good picture of it, where air comes in and around, seals that air to keep the oil in the bearing.
Can you turn the light off just for a
Yes.
moment? There you go.
Yeah. Questions on that? And air, if there's any passing of air and oil, air should seep into the oil, because then that goes back through our big scavenge lines, goes to the scavenge pump, gets that removed. We should not have oil seeping into the air. So, fun KT6 fact. Because of where the bleed air is taken, that is used then for cabin services, airframe services. So if you turn heat on in your aircraft and you smell oil in an aircraft that has a PT6 engine, that means your labyrinth seal is probably failing, allowing oil to leak into the air. That air is then used to heat your cabin. And probably what most likely happened was the last pilot had a really hard landing and that whole shaft went ka-da-wing and failed your labyrinth seal, busted it.
How's it pronounced?
That's what?
How's that pronounced?
Not Boeing, Boeing.
Going?
So yeah, if you smell oil with your cabin heat on, PT6,
You know, we didn't talk about this during bleed air, but what if you turn your bleed air on and you smell something that smells like rotten guts?
Ooh.
Bird strike, bird intake into the engine?
You'd smell it before you notice something going through your engine?
engine, when you have a good manufacturer, will be constructed so that it's assembled in separate modules. So here we have our fan module, front frame module, compressor module, combustor module, high pressure turbine, and low pressure turbine module. The PT6 is split into, right here, you can pull off this front section, like we talked to do a hot section inspection. So that's a module engine. Makes maintenance way easier. So modules are designed to be more easily removed and replaced with a minimum of manpower expenditure. So save on your people needed, makes it a lot easier. Recording maintenance. Because of the nature of module maintenance, the FAA classifies most modules as a minor repair. So you don't have to have your Form 57. But if you overhaul a module, that is considered a major repair, then you'll need the 367. Another note, when you're working with turbines, and especially PT6, if you are going to send it to an overhaul facility, it's very wise to use what is called a DOF shop. And that stands for Designated Overhaul Facility. So they will guarantee warranties, they will be audited by the engine manufacturer. They have an official relationship with the manufacturer. They use approved consumables. They can speak to the manufacturer, perform investigative work. They are expensive. So if you're not going to use a DOF shop, you might use a gray shop. Remember that because DOF, Designated Overhaul Facility, gray shop is a gray area. Because legally they can perform overhauls, but because they do not have any manufacturer relationship, any warranty you have on the engine gets voided. So manufacturer will no longer support that. And a gray shop does not necessarily use manufacturer approved parts. They're legal and they're cheaper, but it does void warranties. So if like you want overhaul engine, but maybe it won't go on an airframe and use it for something else, use a gray shop. But if you're flying that engine, you want to maintain warranties, go to a DOF shop. Questions yet? Test cell maintenance. So an engine might require an integrity check. And then it'll have to go to a specific test facility after manufacturer, heavy repair, and some minor repairs. So depending what minor repairs are happening to it, it may need an integrity check and a test cell. These are specialized facilities, and they provide operational data that is beyond the capability of the aircraft cockpit. So it'll have a lot better sensors to set up on your engine. Test cells are also used by repair facilities to help troubleshoot engine malfunctions. They can leak test engines after minor repairs. They can perform research and development and tests after modifications or many other maintenance support reasons. Question on that. Then TBO, or time between overhaul on turbines. So it's the time in hours or engine cycles that the manufacturer recommends as the engine or engine component gas turbines will be about between 3,000 and 5,000 hours. PT6 recommend 4,000 hours, but at half-life, you need a hot section inspection where you split the engine. So at about 2,000 hours, you do an HSI, and then 4,000 hours, the complete overhaul. Large commercial turbine engines do not generally have hard time between overhaul limits in hours or cycles, so it'll depend on individual components, the individual module, and hours and cycles on that, or the on-condition maintenance. So doing routine inspections, if it passes all the checks, keep going. If there is something that is giving trouble, then take it down and overhaul it. Questions on that, or anything to add?
The thing I would add is that typically in a turbine engine, like all of your turbine rotor blades or hubs or discs, whatever you want to call them, and even a lot of the hubs for fans and stuff like this, they typically are life limited. So, you find that in like your chapter 4 limitations and stuff that, when you reach, let's say for instance, an example, when you reach 7,000 cycles on your HP turbine discs, get rid of them. You'll find that quite common, to have life limits on those components.
And with a cycle, is that from, I'm trying to remember correctly, from wheels up to wheels down
That's correct.
cycle on an engine? So it's not a start up and shut down.
Yeah.
It's actual wheels up, we're off, we're flying to wheels down is what's considered an engine
And that's
cycle.
the norm, it has to go through a start, a full power takeoff, and then a landing and a shutdown to constitute a full cycle. Now, one of the helicopter engines, Safran, that's made in France, they are now saying if you start the engine and shut it down, that's like a quarter cycle or a half a cycle. So now it makes recording a lot more complicated. Things like that. So, but anyways, it's typically a takeoff, a landing, and a shutdown constitutes a full cycle. So if you're going to track on a jet, if you're going to track landings and cycles, they're usually one and the same. They're kind of interchangeable. Because if you're landing the aircraft, that means you're doing a cycle on the engine.
Question? So, what if your engine has been set for a bit? What if you need to put it in storage? You need to preserve it. And our biggest thing, our biggest enemy, just like our airframe, is corrosion. So whenever you go to preserve an engine, you gotta think corrosion control. I won't give you all the references, they're all over the place. But it's going to, how the way that you preserve the engine would depend on length of time. Is it 2 weeks or is it a year? Are you shipping it over to Papua New Guinea or a Kodiak with jars? And before you preserve it, you need to clean it and wash it. And then the oil system and the fuel system will each have their own special procedures to be preserved. So main goal is, these are all engines that apparently, it could be just wear, but were not possibly preserved correctly. This one is a little component inside a fuel pump, so that's not good. So main goal is, yeah.
The best friend of a turbine engine, probably pistons are the same way, I would think too, is operations. If it's operational, you're in good shape. So the worst thing that you can do to an aircraft is leave it sit. So to give an example, I took care of one airplane where it says if your airplane's going to sit for 4 weeks or longer, do a short-term preservation on the engines. Well, the heck with that. It's more fun to push it out every 2 weeks and just run it. long as you keep operating and that oil and everything operating, you're golden. You let it sit, an airplane sit for months, and that's the worst thing you can do to it.
So stop the corrosion monster. Happy Friday. So it will depend on the length of time or period of inactivity, and that will be manufacturer specific. If it's staying on the airframe, there's a short term typically that's going to be sitting more than 7 days, but less than 3 months. There are certain things, certain steps to take. But then if it's long term, you're taking it off the airframe, it's going into storage or going for a long ship ride, then there will be a much more extensive process that you'll need to follow. Some examples. So this is from PT6. So here it has 0 to 7 days, maybe left inactive, no preservation or protective requirements provided, your engine is sheltered, and humidity is not excessively high, not subject to extreme temperatures. And then 8 to 28 days, no preservation, providing openings are sealed off, and now you have a more strict requirement on humidity control. And then 29 to 90 days, the fuel system gets preserved. Over 91 days is going to be a full, extensive preservation. The beach jet engine, the day 215, just has a nice chart. And has 0 to 7 days, what do you need to do? Up to 28, now I gotta watch humidity and seal it. Up to 90, now I gotta preserve fuel. Over 91, you gotta do all of it. For the oil system, first of all, it gets drained and then flushed with special preservative oil. So this would be different than the regular oil you ran in it. It would be special preservative oil to really prevent corrosion. You might spray accessories, exposed surfaces with oil. That'll really depend on the engine. And then install plugs, caps, and covers to seal that good preservative oil in there. Make sure you tag the oil filler cap with what type of oil you used to preserve it and the date of preservation, so they know when that started from. So some manufacturers, I don't have it up here, but will say, oh, you should spray the compressor and turbine ends with a specific preservative oil, and then others specifically caution against that. So you absolutely must go to your manufacturer's maintenance manual. Don't just do what Joe Schmo at the shop down the road said he did last year. You must go to your engine manual to do exactly what the manufacturer recommends. Fuel system, close, disconnect, cap appropriate lines, flush the fuel system with preservative oil. And then there may be a motoring run to get it worked all through everywhere it needs to go, and then cap and reconnect lines as required.
I got a question.
Yeah.
This is jogging my memory. Did you talk about anything about like removing a component, sending it in for repair?
Not
Like for
really.
instance, a fuel control or anything like that?
Not so
You have
much.
to be really aware of this. I don't think I mentioned it during our chemicals and stuff like that. But it's a $10,000 fine if you ship anything, like on FedEx or air or anything like that, that might have a flammable fluid in it. So let's say, for instance, you take fuel control off, you want to send it in for overhaul. If it still has fuel in it and it leaks a little bit, FedEx finds it, they'll come back, they'll fine you $10,000 because you're shipping a hazardous waste without declaring that it's hazardous waste. They're serious about that. That's why all of the various shops will have somebody trained in hazardous material shipping, so they know exactly what to do. So as a mechanic, a lot of times what you'll have to do is if you take a fuel pump or something and you want to send it in for overhaul or repair, you have to flush that fuel out of there and put a preservative oil in it that meets a specification of not being hazardous or flammable fluid. And then go ahead and box it up and send it out. A lot of times you have it's smart to make a statement on a letter, sign it, that you preserve this fuel control, there's no fuel in it, it's preservative oil, and put it inside the box. That way if something happens and it leaks, they open it and go, dang, well, there's a letter in there stating that you went ahead and preserved the oil. So I just wanted to bring that up, that's a big deal. Yeah, it's easily a $10,000 fine if you find out that you shipped something. Okay?
Some other things, once you have your oil system preserved, fuel system preserved, prior to that, you've done a really good engine wash, everything is clean. Now it's dry, sealed up, and you're putting it into some type of storage. You'll need to place bags of dehydrating agent or desiccant, which is like a silica gel. So if you ever get Amazon package, a little bag in there that says "do not eat," that's a drying out agent to keep that humidity super low. So the shipping container gets sealed, and then sometimes they'll suck all the air out of it or pressurize it with dry air or nitrogen and wrap in a vapor-proof storage bag. That bag can be vacuum sealed. And then you need a way to know what is happening inside of that container or bag, however it's packaged. So you can have a fancy humidity indicator that will tell you what's going on inside, or at scheduled intervals you have to open it all up and look at your little indicator to see if you have good humidity, then seal it all up again. If it's an older style, blue is safe, pink means it got very humid, unsafe, needs repackaged, or yeah, you can have a nice little electronic one that's you can see from the outside. Question? And now, congratulations. You have made it through all of the official motions. 2 days yet to go, and you made it through the official. Question. No, Kurt, he's the one that keeps me surviving. Any pressing questions, or we'll start review for the final on Monday, so we'll start going back through some information. I do want to say, yesterday, I did grade all of the, was it lab number 1 that was in the Brayton cycle? All the ones that were submitted, and I was very pleased with what I was seeing. There's a couple of people had a couple points they're missing some stuff, but overall, everyone had the main ideas correct. So that was very encouraging. It's like, all right, you're getting this. Some of you have been listening. And then, reminder, starting Monday and into Tuesday, we'll be doing the oral final on airflow components, pressure, temperature, volume, what's happening, where it's happening, why it's happening, all that stuff on the PT6. And make sure you get a look at the turbojet big model out.
Yeah, well, we're on the lab. If you guys have any questions that you want clarified, just grab me. We'll go over something. I'll be glad to answer your questions for you.
All right, if there are no questions right now, it's a little early, but take a quick little break and come back at 23, and we'll go over lab plan for the day. we just have you do a lab on it to get into the manuals, because it is so specific. Each individual engine. So you'll see some examples in these manuals, what to look for. But we don't really spend time in a lecture talking about it, because if we, very specific to each engine. If you were to go somewhere, they give you special training on those engines. But we will talk about it some in like fuel systems class. So that is that one. And also, now I don't want you to just be studying all weekend, but I don't know that we'll get through all of the prepware on Monday to prep you for the final on Tuesday. So make sure you are going through that on your own to study, be aware. And here, you could do this. I'm not going to require it, but if you want to, you can mark prepware questions that you have questions about, so we can talk about on Monday before your final on Tuesday to make sure we clear up anything. So if there's anything you run across, now that we've gotten through all the lecture, they're like, oh, I don't understand this. Bring it Monday so we can be sure to talk through that.
Is this the last day for those labs?
There will be one more group of Allison combustion section, and I think Grant and Ava, I think you might be able to get this done possibly today, since we're getting out a little earlier than some time. So it might be one more PT6 combustion scope, and then just the last one. Unless these guys get finished, then these guys get finished and started today. But that'll be the plan. So today is Friday, so Randall and Tiki, you'll be on Allison combustion chamber inspection, removal, inspection, reinstallation. Corbin and David and James. No, you're messing up my head. And Shutter. So those three, and remember, once you have it open, make sure you call Kirk over to go over some things with you and ask you very good questions. And then Matthew and Thomas and Zach and Christian, you will both simultaneously be on the PT6 to do the
I can't say that very good.
to do the borescope inspection, insertion, guide, tool thing. Hold on, really. And then Nathan and Amanda and Ava and Grant, you'll be with me. We'll meet right up here initially to go over some stuff. And Grant and Ava, remind me when we're up there, I'm going to have you guys do the first run. So then you can come back inside while we do the second run, if you want, and maybe hop on and get that trolley-whirly done today. So we'll see where we're at with time, if you can stay and you want to see the second run. But just remind me that you may be released if you choose. Questions on that? All right. So Grant, Ava, and Nathan and Amanda, meet me up front in like 5 minutes.